cervicospinal tract. Began in the cerebral cortex, ended in the spinal, ran down the side. Now there's not good names for descending ones. This one is reticulospinal. This was in the reticular formation, so it has to do with arousal going down the spine. So this is sit up straight, because now you're awake. Okay. All right, in general, talked about they're clustered together. That's called somatotropy. They're paired because we are a bilaterally symmetrical animal, the left and right. These decussate either in the medulla or in the spinal cord. It depends on which ones we're talking about. Board on. So descending are in red, ascending are in blue. Kind of shows you their distribution, shows you that they're on both sides. Now the ascending pathways, remember these are going to be sensory. So they're helping discriminative touch. All right, by that I mean, okay, I can feel that these are buttons, a little round button, and we've got some little oddly shaped buttons, and I can feel that this is probably some kind of remote control. All right, so that's being handled by specific ascending pathway. Conscious proprioception, I know that my head is up. I'm aware that my head is up, and that my head is pretty much centered on my neck, and I know where my arms are in space. I'm aware of it. My cerebellum is too, but this is conscious. And then we have the ones going to the cerebellum specifically that are unconscious. That's making sure that my axial muscles are contracted so that I'm postured up. Now let's look at, got some pretty graphic pictures, whoever this artist is. All right, so we light your foot on fire. That gets picked up by temperature receptors. Notice it's going into dorsal root, dorsal horn, synapses, crosses at the level of the spinal cord, then goes up the opposite side, goes through the thalamus, and then up to conscious control of, ow, my foot's on fire. All right, here we have, the razor has cut off our fingers. I don't know what the, anyway. All right, those pain receptors, again, dorsal root, dorsal horn, synapse, cross at the level of the spinal cord, and then up to a different part of the cerebral cortex that's handling sensory input from the hand. Now then, these are handling discriminative touch and vibration, and they cross in the medulla. So here we have a feather tickling your foot. That was much better than a match. Notice, dorsal root, dorsal horn. Now it travels up the spinal cord on the same side the information came in till it gets to the medulla, and then it crosses, and then goes on up to the cerebral cortex. And then the stretch reflexes, this would be like knee jerk reflex when tendons are stretched. These also, well, no, that was cerebellum, this one. Notice it also stays on the same side, crosses at the medulla. The cerebellum, the one that detected I tripped and it stretched tendons, that went to the cerebellum and it stayed on the same side. There you have from your book, Ascending Tracts of the Spinal Cord. Okay, let's now talk about the descending. We have a little bit more to go for this chapter. Now it used to be they were divided in pyramidal tracts and extrapyramidal tracts. It was believed that pyramidal tracts were unique and separate from the extrapyramidal tracts. Now we know that the extrapyramidal neurons are controlling what's going on in the pyramidal neurons. Now we don't call them that anymore. We call them direct and indirect. You have to know extrapyramidal though, because drugs say they have extrapyramidal side effects, which means the person's going to have tremors. Actually, is what it means. They're going to have uncontrolled voluntary movement. But that's the way the side effect is going to say. That's why we need to keep this language in your head, even though we're going to call them direct and indirect. Now, I don't know if you ever read the comic strip Family Circle. When Billy is called by his mother to go home, he never takes a direct pathway. He goes through the whole neighborhood, checks out the dog and the guy mowing his yard, and looks at the butterflies and eats some worms and whatever, before he finally makes it home. So that's one way to think of the direct versus indirect. But in preparing for today's lecture, I looked at more information. I was unhappy with this. And it was actually simplified for me. Direct is excitatory. Indirect is inhibitory. So the direct is causing my arm to reach out, and the indirect is making sure I don't do that. So the indirect is controlling extra movements, and it's limiting the movement to what my conscious control needs to be. So that's another way to think of direct and indirect, because of the neurons that are being released, and the multiple neurons as we go through the different parts of the brain, multiple neurotransmitters being released. Many of them are inhibitory, as they are controlling the smoothness of voluntary movement. So notice we're going through multiple parts of what we've already talked about to make sure that motor neurons are smooth. And I want to make a point here. We need to make that point for chapter 12. I want to make it now. When it says lower motor neurons, it does not mean the ones in your legs. It means lower than the brain. So lower motor neurons are everything from here down. Upper motor neurons is what's going on in here. So the direct system allows fine, fast, skilled movement. So typing, needlework, handwriting. You've got little pathways showing how they are going. Notice that they cross at the level of the spinal cord, unless it is, let's see which one is this one. Tell me which one's the red. The anterior corticospinal tract is crossing at the level of the medulla. You have to actually look in your book to see what that figure says, as to what the difference between those two. And then, again, we have to keep extrapyramidal in our mind, because there are medications that cause extrapyramidal effects. For example, the drug Haldol. Haldol is an antipsychotic. So it's given to people that, look at, she's nodding. Do you have it in your cabinet? Is that what you're saying?
I've treated a lot of people coming off of it.
Okay. So unfortunately, while it may control the psychotic behavior and delusions, it has extrapyramidal effects. It gives them Parkinson's. Therefore, they have to take cogentin, an additional drug that controls the tremors. Now, the problem is that once you're on an antipsychotic, you are now in your right mind, and you are aware of the side effects of your medication, some of which are unpleasant. And so then you decide, well, I'm in my right mind. I don't need to take my meds. These side effects are intolerable. So you quit taking your meds so you don't have the side effects, but now you're no longer in your right mind. And that's the challenge of treating the mentally ill, of keeping them on their meds when they don't think that there's anything wrong with them because they're on their meds. I have a friend who has schizoaffective disorder, which is a psychotic disorder. So she takes a variety of antipsychotic meds, and she has this low level tremor all the time, just this low level going. But at least she's in her right mind.